Hi everyone, it's Sorkin. Today we are going to solve a problem when we are given an amount and we are given a coins and we need to find minimum number of coins to make up that amount. For example, in this case, we have amount of 11 and the coins we are given. So the coins that we need is we can use 5, and we can use the coin in number of times, and 1, which is give us 11, and so that's why we are returning 3 as a result. How we are going to solve this problem? The way we are going to solve, we are going to use dynamic programming bottom-up approach. So let's remind ourselves what's the dynamic programming bottom-up approach is about. It's about that we are solving first sub-problems, that the smaller problems that help us to build up to our solution. So what's the sub-problem in this case? The sub-problem is that if we are going to solve when the amount is equals to 1, amount is equals to 2, amount is equals to 3, that will help us to build up to our solution. Let's show that example here. So to do that, we are going to create an array. Let's call it dp, and we are going to solve the problem for when the amount is equals to 0, amount is equals to 1, amount is equals to 2, amount is equals to 3, and so on. And when the amount is equals to 11, right, as this in this example here. So first let's set how many coins we need to make up amount 0. We need 0 coins. Let's set that here, and for the rest of that, let's just we can set any max value, but let's set 12, because we cannot have more than 12 coins, right? The lowest denomination is 1. So we have 12, just let that 12, we are going to replace that later. So, and now what we are going to do, which approach we're going to use. So first, let's just ignore the rest of the array. Let's concentrate only on the first one. What amount do we need in order to make the amount, how many coins do we need in order to make the amount 1? To do that, we are going to use following approach. We are going to go over our array, right? And we are going to take the minimum of whatever the dp value we have, dpi, right? Or we are going to take the dp value, dpi minus coins, right? Whatever the coins we are taking, j, right? We are going to j plus 1, okay? So let's take this example. So for example, in this case, dpi, we are starting from 1 because 0 is equals to 0. Our I is here. Our I is equals to 1, right? Our I is here. So dpi, what is the value of dpi? dpi is 12, right? So I minus coins j, so we are taking first coin, which is equals to 1, right? 1 minus this 1 gives us 0. dp0 is 0, 0, and we are using 1 coin here, right? So we are using 1 coin, so that's why we are adding 1. So 0 plus 1 gives us 1. Now we are taking minimum from 12 and 1, so the minimum that we are replacing is 1, right? So we need only 1 coin to make up the amount that is equals to 1. We solved this sub-problem. Now let's move our j here. We are moving our j here to the second one, right? Now let's solve the second sub-problem. So to solve the second sub-problem, j is equals to 2, right? J is equals to 2. Then what's the dpi? Is again 12. We are leaving it as it is. So how about this part? So 2, right? I is equals to, I in this case is equals to 2. I is equals to and the coin j, we are taking the first one. 2 minus 1 gives us this part, right? This part gives us 1. 1, right? Plus 1 gives us what? Gives us 2. So we use the first coin, and then so the total amount is we are getting 2. So minimum of the 12 and 2, we are replacing that with 2, right? We are replacing that with 2 by using the first coin, right? So which means that we need 2 of the, so we solved the first sub-problem, and because of that we solved the first sub-problem, we also solved the second sub-problem, right? Because here we use the dp1, we use that how many coins we need when our amount is equals to 1, right? Amount is equals to 1 plus 1 more coin of the denomination 1, which gives us 2, right? Okay, so now let's move to the next coin. Now we can also use the, for example, in the first case, we couldn't use the second coin because the value of that should be less than the our amount or equal to that. So we cannot use that in the first case, but in the second case, we can use the second coin, right? We are using the second coin. At this point, our dpj is equals to 2 because we already replaced that, right? And our 2, so 2 coins j is equals to 2. 2 minus 2, which means that the dp0. What's the value of the dp0? Value of the dp0 is 0, and the plus 1 gives us 1, right? So minimum of 2 and 1, we are taking 1 here, right? So we are taking 1 here. So this one is 1 and this one is also 1. So what's that mean? So it means that we solved this subproblem, right? We solved this subproblem here. And we solve this subproblem the same way we are going to solve this subproblem based on the subproblems that we already solved. And at the end, when we are here, we are going to solve the subproblem of the amount 11, which is in our case going to be equal to 3, which we are going to return here. Okay, first thing that we are going to do, let's create our array dp dynamic programming. We are going to store our amount, where we're going to store minimum amount of coins needed for that amount. So it's going to be the size of int amount plus 1 because we are also considering 0 index for our case. So let's fill our array with the amount, fill our dp array with the values amount plus 1, right? Amount plus 1. So now, and also for the value is equals to 0, right? When the amount is equals to 0, we need 0 coins to build up that, right? So we need 0 coins when the amount is equals to 0. Okay, now let's go and go over our solution. So first thing is, let's put our I here. So I is less than or equal to our amount, right? So, and I plus plus. So we are incrementing our I. And now let's consider for every coin that we have. For that, let's use I equals to j equals to 0. J is less than our coins length. And j, we are incrementing j. So first thing that we are checking that if whether or not we can use that coin, right, in our case. So for that, we are considering coins j if that is less than or equal to our amount, right, to I. So otherwise we cannot use it. So if it's not, if it is, then in that case we are selecting the value for our amount. So we are taking the minimum of dpi, right? dpi. So the amount that we have at that moment, which is by default, when the example of 11, it's 12, or we are taking that the dpi minus the value of our coin, so coins j, and since we are using that coin, we are adding 1 plus 1. And at the end, once we exit this loop, we solved all the subproblems, we build up to our solution. So now what we are doing, we are returning dp amount. So we are returning dp amount. But if it is more than our amount, it means that we haven't found coins that make up to our amount. So if it's more than our amount, then we are gonna return -1. Otherwise, we are returning our DP amount. Okay, let's run it. Okay, it should be outer +1 here. Okay, great. It works as expected. Let's calculate time and space complexity. What's the time complexity of this solution? Time complexity is we have two for loops, right? We have one that is where we are going for each amount, right? And also we are for each coin. So it means that it's going to be A multiplied by C. A is being the number amounts, right? Multiplied by the coins. So by the size of the coin multiplied by size of the amount. So how about our space complexity is determined by the size of our array DP, which is in our case going to be the size of our amount. So it's going to be A of A. Okay, hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.